Alright, Mr. Hong here with another video, and today we're going to be talking about something really interesting. So, let me introduce the topic of today with a story. So, once upon a time, Mr. Hong wanted to buy his first car. So, let me just draw me. And I want to buy a car, like... There's my handle, there's my door, there's a second door with the handle, and there's me with the wheel. Okay, so let's say for example this car was $20,000, which is pretty normal nowadays for you to buy a brand new car in $20,000. And we all have that idea that once you leave the parking lot with a new car, it starts losing value. Value, not values. As in, your car becomes less worth it. As in, like, after a year, it becomes, it could be around like 19K. And after 5 years, it could be like 15K. And like after 10 years, it becomes like 10K, and then so on and so on. It becomes 5K, then it ends up being just useless. So, how do we calculate that? And today we're going to be talking about how you can calculate how much a thing will be in the future, if it's going to be a more beneficial growth or a bad growth, such as like the car, which is this concept right here. This is called depreciation. Depreciation. Something that appreciates or goes up in value is like real estate, your investments, a bank account maybe. So today we're going to be talking about how we can calculate that mathematically. And we have to use exponential functions to help us calculate these things. And we have some formulas that were built into this, but let's get started by talking about the two main ways, or I guess the one of the two equations for today. And this is if compound, or like let's say for example you have like a $10,000 bank account, but the interest or like the money you gain by holding that money inside this bank account only gives you money one time a year. There's an equation for that, which is A equals to P 1 plus R over to the power of T. I'll write that better. And I'm going to be labeling my variables, and A of T, this is the total amount after T years. I guess I could write that better, but I'll write the next one better by zooming in. Give me just a moment. Okay, so P, which I'll highlight, this P right here is talking about the initial investment. As in, if I put in $5,000 into this bank account, how much will I get after? The AT is after, the P, or the little p, is the before. So it's the initial investment. I put in $5,000 in the beginning. The R stands for rate. So this is the rate. And I'm gonna put a star here and make it Make it become a decimal. In the real world, like, we can all agree that when we talk casually to our friends or even to our parents, we don't use like proper grammar. Or even when we text, we don't use proper grammar. And that's because proper grammar ends up being like, honestly, it becomes really inconvenient. But there's also a thing like that in math. We say percentages versus decimals because it's easier to say 34% than 34 hundredths. So if I say in a question, oh, it has this percentage, you have to convert it into a decimal before you put it into the equation. The T. The T is talking about how long you're going to be keeping this investment inside the rate of change. So T is talking about time. So this is one variation, and this will be the easiest type of question, which, where's my cursor? Which pretty much is saying like, you're only gonna be getting paid once per year. The amount is still the same because the rate is still a rate, but how often you get paid will be different, and you're gonna be able to see the difference between getting paid once per year, getting paid many times a year. And if you think about it, getting paid many times a year is better. If you have a job and a job says, okay, I'll pay you $100 a day versus I'll pay you once per month, but they still pay out to be the same, you always want to take the job that pays you every day. How often, if it's the same amount of money, how often it is another variable change that you can change to benefit your money. So let's talk about compounded n times per unit of time. And this is a very long equation, but it becomes a lot of sense. So I'm going to write it for you. This is P 1 plus R 1 plus R over N to the power of NT. So once again, I'm going to choose the same colors as I did from the previous. Why is my highlighter not working? Okay, here we go. I'm going to be using the same color coding for my A, my P, my R, and my T. So everything looks very similar to the first equation that we learned. What's different is this n right here. I don't know what n is equal to. And really, the way that we talk about n is talking about how often per year. How often per year do you get paid to for your interest rate? And we talked about it. If I get paid yearly if I get paid once per year, and I'm talking about per year, my n is 1 because I get paid once per year. So monthly, how many months are there in a year? 12, and so on and so on. So I want you to try to fill this table out yourself. The time for the video right now is 9 minutes in. So try to fill out this table as fast as you can, or not fast as you can, as accurately as possible. So I'm gonna give some time. 5, 4, 3, 2, 1. Okay, quarterly. If you think about a quarter, 25 cents is equal to $1. 25 cents is equal to 1/4 of $1. So quarterly, what that means is 4. So 4 times a year you get paid. Weekly, there's 52 weeks in a year. Daily, there's 365 days in a year. So if we know this information, we can calculate how much money you can have for free, but depending on the rate of change. So let's try example 1. Example 1 says, say you put $1,750 into a savings account. For this particular bank, you earn 0.8% interest compounded monthly. How much money would you make after 5 years? So the first thing you always want to do is label your variables. And look at this monthly. Please switch. So this monthly right here, this is talking about how often I'm getting paid, which is actually my N. So this is going to be 12. So I would like you to try to fill out these variables yourself. So the time right now is 10:45. Okay. 5, 4, 3, 2, 1. Okay, so the P, the initial amount of money I paid, is actually going to be this 1750 because I put this in before my 5 years. 175, 0.00. My rate of change is 0.8, which is 0.8%, which I need to convert it into 0.008 because I need to make it into a decimal. I have to. You must. If you don't make it into a decimal, you're going to get some crazy number. And the time, let me see. The rate is right here. The principal's right here. The time is right here. 5 years. So time is 5. So let's try to use this equation real quick, which is AT, which is the after. I'm trying to find how much money I would make if I put it in my savings account like this. 1 plus 0.008 over 12 to the power of 12 times 5. So I need to use Desmos because Desmos will help me really just solve this question for me. Okay, so I'm back in Desmos and I have this equation right here. 1750. I'm going to write it exactly the way I'm going to write it or how I've written it in my question. Divided by 12 to the power of I'm going to put another parentheses to the power of 12 times 5. So I make $1,821.39. And that's how much I made for free after 5 years. I didn't do any work. I didn't put any extra money in. I really made, quite a substantial amount of money. So I could do this equation subtracted by my investment, which is $71. I made $71.39 for 5 years without sweating or doing anything. I made it for free. And that's how you know the term the rich get richer, because the rich has enough money to put into the interest account to make them more rich. So you can start this, and it's highly advised that you start this right when you turn 18 or get at your first job. So example 2 is talking about, now we're going to be doing the same numbers. So let's read this question. Example 2. Say that you put $1,750 in a savings account. For this particular bank, you earn the same amount of interest rate, which is 0.8%, but instead it's compounded weekly. So how much money will you make after 5 years with the plan compared to example 1? So these numbers are the exact same, but the only difference is that n does not equal 12. N equals to 52. So really, everything inside my question is still the same. So first, I want you to tell me what example 2 is equal to. Then I want you to say I want to do example 1 subtracted by example 2. So try to do both of these things before we continue the video. So let me give you 5 seconds. 5, 4, 3, 2, 1, 15, 20. All right. So if I put this into the, I'm not going to show you this time how I did that, but just know that example 2 ends up being 1821.41. So look at the total right here. So this is 39 cents, but this is 41 cents. Yes, it's like 2 cents. It's true that it's 2 cent difference, but it's more beneficial for you to do weekly than monthly. The more often you get paid, you'll get more money. 2 cents is still more money than not having 2 cents. You need to think frugally for you to be able to be financially stable. Let's look at example 3 now. A planner for the city of Denver predicts the population to decrease by 0.5% every year. The current population of the year 2020 is about 705,400 residents. So calculate the population in year 2050. So how many years is 2020 away from 2050? And this is where I'm going to start writing my equation. The principle is, well, the number that we're starting out with is 705,400. My rate of change is 0.5%. What does that equal to? Let me give you just like 5 seconds. I'm not going to write an Edpuzzle question for this. It's going to be 0.005. And the time should be 30 years. So my big question is, why did I not choose, or why did I not put n? And the reason why is because my n is equal to 1. If my n is equal to 1, I use this first equation that I talked about in the beginning of class today. So that's AT is equal to P1 plus R over to the power of T. And now all you gotta do is plug and chug, which is 705,400 times 1 plus 0.005 to the power of 30. So let's try typing this into Desmos. 705,400 times 1 plus 0.05 to the power of 30. Oh, but the thing is, my rate of change isn't growing, right? The question said how much it would decrease. So my rate of change isn't really 0.5%. It's actually negative 0.5%. So this addition sign right here should be a minus sign. That means that this addition sign right here has to be a minus sign. So let's change that in Desmos real quick. So my population, it becomes 606,915. 606,915. Nice. And that has to make sense too, because I'm saying that there's going to be less people in the year 2050 than the year 2020, which is the present time of the question. So this makes sense. Nice. So if we compare how interest is compounded, then it becomes more clear that the more times you get paid per year, the greater the return, as we showed from example 1 and example 2. It's better for you to get paid more often than not. So this table right here is really to show you how nice it would be for you to get paid annually, monthly, daily, every minute, every second. So notice how the number of times interest is compounded per year you're gaining more and more and more. So this is 2,000. This is 26,000. This is 27,000, or yeah, 2,700. Sorry, and it starts getting less and less significant because this is like this is $613 more. This is what, like $100 more. This became $4 more, and this is really like pennies. So why is that? And that's because it's the same kind of graph as my exponential graph. As in, if I have a graph like this, and my money looks like this. Looks like this. Oh wait, no, it doesn't. No, it doesn't. It looks like this. How does it look like? Yeah, it does look like this. Yeah, it has to look like that. So notice as we increase the number of times that we get paid, it's better. But what if I told you that we get paid constantly, forever and ever and ever? Like every single moment that you're alive, you get paid. There's an equation for that. So this is called P. This is called compounded continuously. The key word is continuously, because if I compounded per day, it would be n equals 365. If I said monthly, n would equal 12. Constantly, we can't quantify that, but we use the term E. And this is what we learned in the first 2 days of this unit, where I said that P is equal to initial investment, E is equal to, well, E, R is equal to rate, and T is equal to time. So in example 4, suppose that you want a contest to start at the start of 5th grade and deposit $3,000 in that account that pays 5% annual interest compounded continuously. So once again, this word continuously is like your trigger word, as in like, you know that you use this PERT equation to help you out. So P is equal to 3,000. R is equal to 5%, which I have to convert to 0.005. To the nearest dollar, how much will you make after 8 years? The time is 8 years. So it becomes very simple. 3,000 e to the power of 0.005 times 8. And I can really use Desmos for this. I'm going to delete all these. 3,000 times e to the power of 0.005 times 8. Okay, I guess I need to put parentheses here. Okay. 3,1,2. Oh, 3,1,2,2. Oh, I moved it too many times. It should be 0.5. 0.5. And the reason why is because 5%, it looks like this. 5%, right? Go 1, 2. So it becomes $4,475. So that's a lot of money. So continuous compound is very nice. If you ever see continuously compounded, no matter, or I guess the rate does matter, but you definitely want to take the continuously compound. That's why it's so rare nowadays for it to be continuously compounded in a beneficial way. So let me give you some time to do example 5 by yourself. I'm gonna say that the time right now is 24.55. So I would like for you to try example 5 by yourself. So I'm going to give you some time right here like this. And you should be able to get $13,256. Oh. And the way that you do this is by saying your PRT. As in this is $5,000. The rate is 0.0975 and the time is 10 years. So it becomes 5,000 e to the power of 0.0975 times 10. So let's look at that. Let me just do it for you real quick. 5,000 to the power of 5,000 e to the power of 0.0975 times 10. And that becomes like 13,255.8. So I rounded to the nearest dollar, so I got this. Nice. So hopefully you like this lesson a lot more because it's more applicable to our daily lives, or it should be part of your daily lives after college or after high school and college. So make sure to do your homework, and I'll see you guys next time in this next video. Appreciate y'all. Bye.